Peter. Yes, sir. Undivided attention. I like it. I like it. I like it. I like it. Sasha's going to come in with some stuff that'll distract for a second longer, so then you can really give me undivided attention. But I like this conversation that it came into. We were talking about Move. We were talking about Rust. We were talking about Rust smart contract languages and things like that. Ink is a Rust smart contract language that I really love and is super nice to use. Let's go ahead and throw that slideshow on. So basically, how this is going to go is I'm just going to give a little brief overview of Polkadot smart contracts and very high level, and then we'll actually dive into some actual things. So like I said, if there's anything you want me to double click on, dive into, we can do it. It's going to be an informal workshop. There's not many of us here, so feel free to interrupt me. But basically, Polkadot is built a little bit differently than other chains, or at least it used to be like that. I know more and more chains are transitioning to this same model, where you have the relay chain in the middle, and then all of these parachains that connect to it. And basically, they get this shared security from Polkadot. So that makes launching blockchains, it was the first step in making launching blockchains really, really easy. Because now, I want to launch a blockchain, and I don't have to go and build a validator set of thousands of validators to have a really decentralized network. With Polkadot, I can just connect, and I have all of that access to thousands of validators so that my network is actually decentralized. It's one of the reasons that Polkadot is up there. If you look at objective stats like, I don't know, Nakamoto coefficients, if you know what that is, Polkadot is one of the most decentralized networks. But one of these things is that parachains are still harder to deploy because at the end of the day, it is a blockchain. So it doesn't matter. It is way cheaper on Polkadot, but there's still the problem of you have to run all of this hardware. So when you get people like university students, I was one of those not too long ago, and I couldn't afford to launch a parachain, but I can write a smart contract. I can write something and deploy it on someone else's infrastructure. So what does that look like with Polkadot? What is a smart contract for Polkadot? And it's Ink. Ink is a Rust-based smart contract language with a little bit of magic inside. And that magic basically just makes it specific to smart contracts on Polkadot. To get a little more technical, it compiles down to WebAssembly, which runs quite fast. And then in the future, it's going to compile to an even faster VM that's just really, really quick. So Rust plus these WebAssemblies make Ink just a really, really powerful language. But now comes the question, why Rust? Why not Solidity? Why not, I probably won't go into Move too much because I didn't know too much about it, but why Rust? And my opinion is I come from a background where I programmed cube satellites. I used C. I programmed things that were mission critical. So basically, when it gets into space, if something goes wrong, we're screwed, right? We can't change it. It's just stuck there. And more or less, blockchain is in this same line where you've got immutable code that's there. It's got potentially millions of dollars flowing through it. If it breaks, you're kind of screwed and you just lost all that money, right? Now, Rust is a language that really, really helps with the security. It's got memory, safety, and type checks, and these really cool things. And personally, if I'm writing a smart contract that potentially has millions of dollars flowing through it, I want to use the language that Apple uses, that Firefox uses, and Mozilla uses, the language that's used in satellites, language used by Amazon, the language that Microsoft is rewriting parts of Windows in, the language that the Linux kernel actually uses now as well. Parts of the Linux kernel uses Rust. And Linux runs the world in the shadows. You know, you don't always see it, but Linux runs the world. So personally, that's what I would like to write my blockchain application with. And that's what Ink is. So that's kind of my high-level overview of why Ink, why Rust. And for some context, Ink, Gavin Wood, the creator of Ethereum and the creator of Solidity, left Ethereum to create Polkadot. That company then, created Polkadot, but it also created Ink. So basically, Gavin Wood, the creator of Solidity, also founded the company that now has created Ink. And yeah, that's kind of my high-level overview of Ink. So far, any questions, or you guys kind of want to jump into some demos and see it?
I was just talking to Bill earlier,
Nice.
Bill Laboon, and he was saying that parachains are able to import different modules, even multiple modules, so that you can have a parachain that runs the EVM and runs, Ink and runs, CosWasm or whatever. each of these being able to be imported as modules. Is that not true anymore? I thought that kind of made it kind of language agnostic on the parachain side.
Yeah, 100%. And like Astar, for example, it's a parachain on Polkadot. They have EVM and they have Ink smart contract support. And technically, the module that runs Ink smart contracts doesn't just have to be Ink. So there's like a TypeScript version. There's a version that Vala has done where it's like a kind of like a JavaScript engine. It actually compiles down to Ink, but still, like it is agnostic in that sense. And actually, Parity right now is also working on a feature to bring in Solidity developers too, not on the EVM. So that way they get the benefits of what's going to be the Polka VM. Basically, they're going to compile Solidity and connect it to this module's interface. It's called Pilot Contracts. Yeah, that's your question? Comment?
Yeah, I think so.
Yeah, cool.
So you don't need to use Ink on Polkadot. It's basically the
You don't
answer.
have to. Actually, the Polkadot relay chain itself does not have smart contracts. It has to be a parachain.
I do that.
Yeah, it has to be a parachain. So, and one of the cool things so I have my own parachain that I'm launching. It just uses the dot token, so that way somebody can deploy an Ink smart contract with dot. But the cool thing with Ink is that it can basically easily interface to all of these things that Polkadot has to offer, right? So you've got all of these services and these things that Polkadot can compose. And with Ink, we can basically interface those two worlds together to basically do really powerful things with just a couple lines of code. Because Polkadot was built on the Polkadot SDK, or if you know it as Substrate like I do, then it's a framework for building blockchains. So you can write your customized functionality and then expose that to Ink smart contracts. But what we are going to do is I'm going to actually try to demo some stuff. It's going to be a little awkward at times because I have one hand and the keyboard, and I usually need two hands for a keyboard. But what I wanted to basically do is I wanted to go over and demo some things. First, we're going to start with basically some things to help you be able to build a decentralized application with Ink. This will be from front end all the way to the actual Ink smart contract. So Inkathon is something built by a company called Scio Labs. And it's a really cool front end that you can just pull up. It connects to your contract super easily, and then you can launch it. And for hackathons where you've got, well, less than, 24 hours at this point, less than 12 hours, then having these types of things is super useful. So we're going to back out of that presentation. We're going to open up my Rust rover. All right. So here we have Inkathon. This is basically a boilerplate front-end template that connects to smart contracts super easily. So basically, like, you can just set it up, and then we can actually just, after you run a pnpm install, the README walks you through all of that. You can launch it. It's starting. You guys can see that. Good. All right. Throw this guy open. Okay. Increase fine. Okay. So this is why Inkathon is so cool. So basically, right out of the box, we now have a slow internet connection that needs to load first. Okay. But basically, what this is going to show is it's going to auto connect you to any Polkadot wallets that you have. So I'll connect you there. It'll pull up a default contract that's actually deployed onto an actual testnet that you can then use. And what's cool about this is that this Inkathon has a bunch of components that you can then pull to work with your Ink smart contracts. So it just makes things super quick and super easy for you to do. Unfortunately, Wi-Fi is not working the best right now. We can try to switch it over.
The internet too. Yeah.
Okay, well, that's a little unfortunate. We won't dwell on it too much. Basically, it's got some components that you can reuse to make your Ink smart contract development super quick, so that way you can get your stuff ready for tomorrow. And out of curiosity, is anyone planning on building with Ink smart contracts for this hackathon? For the hackathon or just in the future?
In the future, generally.
Perfect. Yeah, we can go over that.
I'm curious, why would you choose Ink?
Well, I mean, we're big into Rust. Like, we started exploring a lot of Rust languages. The team really likes it. Like I said, I don't really get to code anymore, but Ink's a super fast language. We're kind of bullish on Polkadot as a whole. We're not seeing like a huge movement of developers towards Ink. Like, I understand there's been a lot of friction in the space in general. People don't want to move out of Solidity, and it's something that we really like to do. So it's always a good opportunity. That's like the base case for why we want to do it. But we're seeing some opportunities come up.
Yeah, for sure. And I mean, there's some issues, I mean, even in the ecosystem where like people need to support Ink, but then it's like, okay, how do you then deploy a smart contract with Dot? And realistically, like that wasn't something that many chains did. Now, I'll just show my own chain, it'll just basically support Dot. So if you want to deploy on the Pop Network testnet, you can do that right now with just the relay chain token. And then it's deploying with Dot, essentially. But yeah, so this is an actual Ink smart contract here. And this is a simple one. So like I said, Ink is just Rust with a little bit of magic. It's what's considered a domain-specific language. The domain in this case is Polkadot smart contracts, right? So there's a couple macros here that do some things to set it up for Polkadot. But everything else is just Rust. So that means you inherently have your overflow protection, your underflow protection. So that way you can't accidentally increase and then go back to zero, increase your number and go back to zero, and then you're screwed because you've got a financial application and somebody has a balance of zero now, right? Those things are inherent to Rust. And the compiler for it actually does a bunch of checks for you. It's called cargo contract. One-hand typing. Cargo contract. This cargo contract actually does a bunch of checks and.
Sorry, I meant for you to finish your sentence before I.
You're good. You're good.
Well, now you'll listen to me.
Okay.
When you're developing an Ink, you get to use just a cargo, or is there a separate package manager that's kind of like built on top for Ink specifically?
No, you get to use cargo. So if
That's
I go
pretty
to source and then cargo toml, yeah, this is all just cargo. So what's cool is most things that as long as they don't as long as they have what's called a no STD, no standard feature, then you can use that in Ink actually. So that means Rust, which is a language not specific to blockchain, has a bunch of tooling. It's got a bunch of crates, a bunch of libraries that you could then potentially use in your Ink smart contract, which is pretty cool, right? So that's why I like Ink a lot, is because it's not just developed by blockchain. Because at the end of the day, blockchain is still niche. There's, I think, like 200,000 Solidity developers. There's 2.8 million Rust developers, right? Some of these include very large companies that actually improve Rust in general. Ink has a lot of those benefits. So for example, Cargo Contract has been able to integrate with a lot of these tools. So that way when you build your contract, it'll spit out a wall of warnings if you have anything that's unsafe. So if you're doing incorrect math, it'll tell you this is incorrect. And once again, this isn't even blockchain specific. This is just Rust in general. So yeah, here's an actual Ink contract here. This one is super basic, but you've got an event here, which is just a struct. And you say, this is an account ID, and this is a string. And then you have this storage attribute here, which then defines your storage for your smart contract, which I think is super cool, because my storage is just a struct. So I've got a struct, and then I can define some things, like message here, which is just a string, okay? So then I can then modify this message to what I want in my smart contract, and it'll actually update on-chain in blockchain storage. And then this is your constructor here. So this constructor attribute basically is when I create my Ink smart contract, I mean, most people here, I imagine, are familiar with constructors. What are the things that I want to construct at the start, initialize at the start? So in this case, you can provide a value, and it sets that value then to the storage, actually to the storage when you create the smart contract. So when I create my smart contract, I can set it with default values and initialize it. This is just default. And then this message attribute is basically, what are the functions that I can call on my smart contract? What are the things that people can use? What can my front end use? And in this case, it's this greet one. So if this little UI here was actually working,
I think it should work now.
Okay, actually, that one was my fault. I need to relaunch it. That was my local internet. We'll run fancy fish, main PM. Okay, let that run. Here we go, and a little loading. Hey, there we go. Okay, so this is my testnet wallet, auto-connected. And then this is connected to actually the Aleph Zero testnet, because Scio Labs works very closely with Aleph Zero, so that's their default.
Zero is just another app chain that is really fast block technology.
It's really, really sexy when you look at it. It's like 1 second blocks and just like things just spit out like that. But it's Ink based. They have over, I think, 1,000 Ink smart contracts deployed on there.
They're a parachain?
They're not actually a parachain. They have a parachain to bridge their solo chain, but they do some fancy zero knowledge stuff to get 1 second block times.
Yeah, if I may add, they've customized their consensus mechanism so much that so out of zero have customized their consensus gadget and they use kind of DAGs or whatever so much that they can't be a parachain, right? Because it's just so customized that they have 1 second block times. But then their architecture to bridge to Polkadot involves having a dedicated parachain that will communicate to this solo chain. So literally, out of zero has its own validators, its own consensus mechanism, etc. You know? Yeah.
Are they like pretty centralized in order to operate at that speed?
No, super decentralized.
They have put a tremendous amount of effort. Like how to say, like they've done such a good job because they're so not centralized. Like
Yeah.
given the architecture.
Do they have very expensive validators? I'm sorry, we're distracted.
We can talk about Alice Zero after. Yeah. Sorry.
I don't know how expensive, but it's thousands of validators, so they do a pretty good job. Yeah, so basically, as we saw in our smart contract, we have this greet function here, which basically just takes in, this is a getter. So it gets your self.message, which is your actual on-chain storage. It pulls that when you call this function, and then it returns it. So then in this case, this greeting for this local contract is this rm-rf. That's the greeting, which is kind of funny. If this one loaded, no, internet's not working there. If I had Alice0 tokens, I could update the greeting, and it would then call this set message, which takes in a value, and then it gets the account ID of the person that called it, so that it can be added to the event, and then it actually up here it sets the value. Sorry, up here in this first line it sets the message. It sets the storage of the smart contract. And once again, I think it's pretty simple to do because it's just a struct. So you just get to do self.message equals this new value. And it's now set actually on-chain in the storage. And then here, we're actually emitting an event. So we can get the account ID of the person that called the contract, and then we can emit an event. And for those of you familiar with smart contract development, you'll probably know this already. But usually events aren't actually stored on-chain. So this is just some extra information that you can return. So that way you can index it, pull it from your front end, pull it from your back end, and then do some additional stuff there. But these events aren't actually stored on chain because they can be a little expensive storage-wise. Yeah, and then another cool thing about Rust is it actually has its unit tests features are quite powerful. So just right here in the same file, we have tests that you can write, and you can use your struct. You can use your contract that you've defined all locally here just in unit tests. So it doesn't need a chain to run these unit tests. So this right here creates a new struct with the message, and then, Command Z, and then you can do your getter. And then the same thing with set message. You can then use that struct, set the message in the struct, and the unit test will work. Now what's also cool about Ink, this smart contract doesn't have it, is if you need to do those integration type tests, those end-to-end tests, Ink also has that built in. And I can pull up an example here. Yes, it loaded. E2E. Let's actually look at an ERC20. I believe that should have some stuff.
So what we're looking at now is what exactly?
So it's just going into the Ink offers a peace of mind when you're developing because of Rust and because of its testing features. So one of the cool things is it has unit tests built in, just because it's Rust, once again, but it also has end-to-end tests built in too, so integration tests. Yeah, so I believe this smart contract should have that. Those are regular tests. Ink test, blah, 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 blah. Here we go, end-to-end tests. Once again, just written here in your smart contract. And what it does is it can actually connect to a live chain, and then it will just deploy things, set up your contract all right here, instantiate it, and then you can start calling things like this total supply to actually make sure that it works on a live chain. And this is a super convenient feature because now my testing flow and my feedback loop is much smaller, and it's I could be more confident in my smart contract, right? So that when I get ready to deploy it and it's just kind of stuck there, immutable smart contract, I want to have as much testing as I can. So that's one of the features of Ink. I'm gonna pause here. Any questions so far? Any comments? Any thoughts? So far, nothing. Okay, it's okay. I was just gonna say. So, like I said, this can be an informal workshop. What I was going to do is actually going to build a smart contract, and I was going to deploy a smart contract, which, for I think the purpose of the hackathon, could be useful. I'll show. Yeah, you like that? Cool. Let's do that then.
I would put in a smaller, selfishly, I would love to, selfishly, I would love to learn and see the superpower of an Ink smart contract that can talk to another chain, like another runtime.
Another runtime.
Yeah.
Okay.
Like I want to create a smart contract that can buy core time and then fractionalize that.
So if you guys want to see that, I can do that. It's just going to take a little bit of setup time.
Do the basic thing first, maybe. Yeah.
Okay, so I'll deploy it, and then I'll show you some cool things. So what we're going to do is, I've got this fancy thing here. And basically, if you were watching the Polkadot workshops earlier, you'll see some of this. This is just a different smart contract, super simple too. You've got a value here in the storage, and you can flip this. You can basically flip it from true to false and false to true, so on and so forth. Very simple. This is already built. I can build it with cargo contract build like this, and that should build it. It'll run through there. And what it does first is it runs the Rust compiler. It does all the type checks, all of that fun stuff to make sure that your code is actually secure. There's no memory leaks. There's some things like you can't, be using the same mutable variable in different spots. And then the second step is it actually then compiles this into WebAssembly. And WebAssembly is just a type of instruction set that Polkadot uses. Yes?
I'll give you this mic for the video.
Yeah, which specific curves does Ink support in terms of cryptography? Does it just do SCCP 251K1? Does it do 384R1? That's specifically an issue I ran into EVMs. That's why I'm asking. Or is there any other? Because you can import a library to do any curve in Rust, but it's not going to be fast. So I'm just wondering which ones have precompiles to be fast.
Yeah, so the ones that it has built in, off the top of my head, I know for sure it's going to use Blake 256. Polkadot itself uses Schnorr-based algorithms like SR25519s and potentially ED25519 which is still kind of similar thing. Yes, I might be able to poke around the docs though and find exactly what it covers. Yeah. Okay, so back to this. This is basically just, I built a smart contract. It's the Flipper smart contract. And now what we need to do is, what did I put in my slide? So, yeah, this one is onboard.popnetwork.xyz. This is the link that we'll go to. This is nice loaded in. Okay, so this is, I connected my wallet here. And like I said, so basically, this chain that we're deploying to, this is the POP network testnet. It only uses the relay chain token. In this case, the relay chain is Paseo. That's the testnet that we're using. If you need tokens, one, you can talk to me, and I can get you a lot of Paseo if you need it. You can talk to me too. You can talk to him.
Paseo. You can talk to Ravi, because I sent him a lot of Paseo too.
Yeah. So we've got a lot of Paseo in this room. But this is also the official testnet. It's just like faucet.polkadot.io, where you can get your own Paseo too. But if you want more than what this gives you, you can talk to us. Yep.
This question might end up being so dumb, but please forgive me. I don't spend a lot of time on Polkadot. When you get to Paseo, does it go to a default parachain? Because there is no, there's no hub, right?
Okay, so the Polkadot's relay chain.
The relay chain, right? Yeah.
Yeah, so Polkadot, just Polkadot. What it supports out of the box is basically it allows these parachains to connect. That's kind of like the main functionality. Is it's got balances, so it holds Polkadot. It's got,
but no smart contracts.
No smart contracts.
But consensus.
But consensus. It actually has staking built in, nominated proof of stake. So the staking is part of the protocol itself. So you can go and you can stake on people right there, and I don't know what the rewards are at, but it's pretty good. And then yeah, it processes these pair chains, which are essentially rollups. They're called pair chains. So when you do this, the Paseo faucet, I have my Talisman wallet here, and this is on the relay chain. And what's cool is that the relay chain has an address, and then it's got the same address actually on the POP network. So that means I can just transfer it to that. I can basically put my address in here, get some Paseo, and then I can switch over to this one, which is now we've got Paseo on the relay chain. I need that same Paseo on the POP network chain. So we're actually going to move chains here. So it's still all Polkadot. It's still all the same security. We just need to move down a layer. So I'm going to select this guy. We're going to send it to here. And let's do 1,000 Paseo. And just because we're all here, I'll actually pull up the block explorer just to kind of show you. So we'll go here, POP network. This is just the developer portal. If you're doing regular things on Polkadot, do not use this. This is for power users, and people mess up trying to use it sometimes. But it is useful when you are developing. So here we've got a block explorer. These are the collators building blocks, and here we're going to see some events. So we'll go ahead, we'll press submit. Talisman pulls up, approve that transaction. And what this is actually doing is it's sending a cross-chain message that is built in to Polkadot. And it's actually super simple. I wrote this UI in like a couple days, and it uses these cross-chain messaging, and it's like super easy to do. But yeah, now we receive a message from the relay chain. And this amount, if it wasn't processed already, it should go up. There we go. It just went up 1,000 Paseo because it actually processed that cross-chain message and then minted that Paseo from the relay chain onto this pair chain, onto the POP network. So we've got some Paseo now, and now we want to deploy it. So we're going to start with, we're going to go here, which is, I believe I have it in big letters so you guys can see it, ui.use.inc. It's pretty simple. Use.inc is the documentation for Inc. It's actually pretty solid. If you know Polkadot documentation, you know sometimes the documentation is great. The Inc documentation is solid though. The core developers really, they took their time on it. But here we are going to deploy, sorry, my Zoom is messing some things up here. We're going to add a new contract. There's a bunch of networks here. So Aleph0, A-Star, contracts on Rococo, things like that. We want POP network testnet, and we're going to add a new contract. And let me go to find it. Consensus, Flipper, Target, Inc. So yeah, basically there's just going to be an output when you build it. Yeah.
You're not going to deploy directly from the command line?
If you want me to deploy from the command line, I can do that.
No, I don't care. I just was... no, please, sorry, carry on. I was just confused.
Yes, you can deploy it from the command line. Cargo contract supports it. The POP CLI also supports it, so you can just set it. There's just a few more steps when you can just plug it into a UI and play around with it. So we're going to do it the boring way.
It's like whenever I see someone use GitHub Desktop, it's like, okay, I'm sorry.
No, I don't use GitHub Desktop. This is just for workshop purposes. So yeah, we upload the contract there. It pulls in the metadata. What are the constructors? What are the functions you can actually call? Press next. It shows the hash of the contract. This is part of what will be stored on chain. Then we press next, and we can set the initial value if we want it to be true or false. We're going to leave it at false. Next, the amount of weight that's used. In Polkadot terms, weight is essentially just gas. So yeah, I don't need to dive super deep into that. It's just gas. So we'll upload and instantiate. Talisman pops up, approve, and okay, that should go through in just a second. In our block explorer, we'll see in just a few seconds this will pop up, and there we go, contract instantiated. And you may notice that this is using 12-second blocks, but Polkadot has a new thing where I can drop this down to 6 seconds actually, and it processes like 8 times the amount of transactions.
Running a local chain? Sorry.
Yeah, you're good.
Running a local chain, you can change the block time, or you can't change the block time associated with the network that you're deploying on.
Yeah, so right now we're on POP network testnet. The contract can't do this. This is something we have to do at the parachain level.
Yeah, of course. Okay.
But yeah, we can actually, this is a running network that we'll be able to then do a forkless runtime upgrade to then have 6-second block times that process 8 times the amount of transactions that this 12-second one does.
So the block time on mainnet is 6 seconds?
So on relay chain, it's 6 seconds, and then with this asynchronous backing, yeah, so 6-second block times, 30-second finality, and then on the parachain it was 12 seconds, but there's this new thing where you can actually drop that down to 6 seconds, and the transactions will be asynchronously processed. So it's way faster. It's actually pretty nice. But contracts is deployed. So yeah, basically if we press this get here, this is that function that's in our smart contract that gets the storage from it's just this value that we need to store. And right here, that's the value. It's false. And then we can flip it. So this is the actual ink message that if I go here. So this is our storage, right? So we've got this guy, this value. And then here's the messages we have. These messages are the functions that you can call. So flip up here, this guy, will then flip the value. So it's self.value, and then you just do the opposite of that. And then this one gets it. It's pretty simple. So then if we call that, call contract, processing, approve this transaction, and then in just a second, about 6 seconds, this will go through. It'll actually set the new storage, and the value is updated. There we go. Okay, so call is success, and if we do get, it should be switched to true now. Okay, so this is basically just walking through the steps of setting up a contract, deploying a contract, creating some testnet tokens, and then deploying it. Any questions? Any thoughts?
UI is super cool.
This
Really nice tool.
this contract UI? Yeah, it is. Yeah, it's nice, and it has all these things where like when I go to do this flip, it's like it'll do a dry run. That's like, okay, this result is okay. And what's cool is you can actually insert assert statements that when you do this dry run, it'll actually spit out the exact message that you needed in that spot because it's just a dry run. It doesn't have to. It's okay that it's basically panicking in that dry run.
It's sick. It's like Tenderly, except sorry guys.
You're good.
It's
you're
like
good.
Tenderly, except you can actually load up your contracts as like a file to drop in instead of just like having to run, like have the contracts either deployed locally and then like run it, and like gives you a front end for everything. That's super cool.
Yeah, exactly. And ideally, this is Inkathon. If I wanted to, I can then connect this to my Flipper smart contract, and I'll have a front end out of the box that then works with it very easily. Yeah, and it says the amount of gas consumed and auto calculates some stuff for you there. Yeah, so that's deploying. Any questions? You had a question or no? Cool.
The site is ui.use.inc.
ui.use.inc. This guy
Sweet.
right here. Is that big enough for everyone to see? Cool.
So I have a question, Peter. When you deployed the contract, couldn't you have done it through POP CLI?
Yeah, we could do it through POP CLI.
Yeah, because POP CLI is such a well-needed tool in our ecosystem. It's like, it is difficult, guys, right? It is difficult to deploy parachains on Polkadot. It's not there yet. You really need to know what you're doing.
Yeah. So
What the guys at R0GUE are building is making it much easier to do it in one single CLI tool.
yeah. So thank you, Sasha, for the shout out. So since he started shilling it, I'll shill it a little bit too. Basically,
Chill it.
I'm building.
He built this tool.
We built it, and we built it because we worked for, I think cumulatively our team has like over 10 years experience in Polkadot. So we've seen the struggles. When I left from my old company, they took my work computer, and I had to set up a new parachain on the latest version from scratch. It took me like over 3 hours, right? And that's just somebody I've been building parachains for 2 years, and it took me 3 hours. Now with POP, I can do this. POP, new parachain. We'll do POP. So what do you guys want? You want just a regular plain one? You want something that's got assets, NFTs, and fractionalization? You want Ink smart contracts, or you want a fully Ethereum compatible chain?
When
On
it's
Polkadot.
fully Ethereum compatible, do you also get to use Ink, or is it just also like?
That one is just
so it's
Ethereum,
only gonna be-
just EVM.
Wait, we can, and eventually we can make it SUI compatible, right? We can
Yeah.
put the move palette in there.
And actually, somebody is working on a move palette for.
Someone's actually working, yeah, exactly.
So
I don't know what you guys want. Yeah,
We'll do EVM. Unless somebody, anyone? You EVM? Okay. And this is a Polkadot EVM, so it's better. We'll use a specific release of 1.9. We can name it whatever we want. We'll just leave it my parachain. We can name the token, how many decimals we want. Since this is an EVM chain, we'll do 18 decimals. And we can fund these initial accounts so that we can have some dev accounts ready to use. Generates, and there we go. That's set up. So now we can actually switch over to the EVM parachain. Actually, it's my parachain. And this is ready to go. So it's a parachain that we can launch.
So, okay, I got another question about this.
Yep.
Well, when you set up your parachain and you said it took you 3 hours, is there no templating available? Is that what's happening here, or is there other, more complicated? I can't even imagine configuration that couldn't be copied. You know what I mean? Are there no templates that you can just download as DM or whatever?
Yeah.
Zips.
So there are templates. It's just the issue is I wanted a template on the latest version of Polkadot, and there's just so many frustrations. It's like, okay, this is just for most Rust-based things in general. My Rust version was higher than the Rust version that built the template on that current version, so then it failed at building. While with Pop, these templates are there that you can use, and they are going to build. It's not going to fail. It's just going to work.
Interesting. So if I were to contract, I understand perfectly. This is awesome. Very cool.
Yeah, thank you.
Another question? Oh.
Yeah.
Is there any integration with Terraform for Polkadot?
Terraform in terms of DevOps stuff?
Yeah.
Yeah, so all of Parity, the people that launched Polkadot, they mostly just use Terraform and Ansible together, and they had a bunch of scripts and stuff for that. More recently, they've started transitioning to Kubernetes and K8s and things, and they've got some Helm charts you can use, but still lots of people use Terraform.
But what about if I want to have a contract and sync that on chain, is that something I can use Terraform for? Or is there an integration, a Terraform plugin that's going to work with that?
Interesting. I don't know the answer to that actually.
Okay.
I guess so. The purpose of this is Terraform to sync a contract, or
yeah, if I have a contract, if I'm developing a contract and I want to have the latest version on testnet, can I integrate that in the Terraform? Is there a plugin for that? Just if you're curious, yeah.
Yeah, I mean for Pop CLI definitely not. We don't have that, but maybe it's something we can look into for sure. That'd be interesting. And even for one more thing. So if you want to get started with Polkadot development, there's this cool command pop install, where it's because Polkadot uses Wasm and uses Rust, it uses lots of things that are necessary. You can just basically run pop install, and it will install all of these things for you, so that your environment is just ready to go, and it's going to work out of the box.
What package managers is Pop available on?
So Pop, right now we haven't integrated with any package managers. Basically, you can curl the binaries, or you can install it straight from Cargo.
Okay, I can cargo install Pop.
You can Cargo install Pop. Yep, the Cargo install. I mean, if I go to the
Cargo's a package manager?
Cargo is a package manager. Sure, I guess that's fair. So yeah, you can Cargo install it. This guy here, Cargo install locked, and then this is our Pop CLI. Yep.
Okay, awesome.
Yeah. So then, yeah, and then if you already have Cargo, you probably don't need all of this, but you can still install some of it. And
Just check, right? It's not gonna hurt.
no, it wouldn't hurt at all. So it'll detect your OS, and for this one, it's a relatively new feature, so we're still getting feedback on it.
Okay.
But this one will then use Homebrew, and it will use Homebrew to install these things. If you're on Ubuntu or whatever it is, it'll use apt or something like that. What was that?
You can do it.
Oh, okay. I guess
But you have to install it.
you have to install it. I think most Ubuntu developers probably don't want to use Homebrew. Yeah, all the bloat. So we could build that parachain and then we can launch it. And I realize this is a little deviation from Ink smart contracts, but it seems like you guys are interested in this.
We're chilling. It's good.
Yeah, so if we go to something I've already built, it would probably take, 10 minutes to build a parachain. but we have one built right here. So we can just do pop-up and pop-up parachain, and then networks, and then R0GUE. Okay. Hold on. Okay. So what this does is it launches a local network. And what's cool about this is because Polkadot needs that relay chain, we have to have a running relay chain, the Polkadot, and then we have to connect our parachain to that. So with this, you can just run pop-up parachain, and it will automatically source the Polkadot binaries for you. If you're on Linux, this is even better because they're pre-built, so you can just literally install them. Takes a couple seconds. Because this will have to build, I don't want to build it, so I'm going to press no, and I'm going to specify the version I already have. It basically will cache. It'll cache the Polkadot binary, so that way I can switch between different parachains, which is useful for me because I'm a parachain developer. So I can switch between different parachains and just launch it, and it takes just a couple seconds. So with that, this is verbose output, so it's kind of ugly. But if this actually launches my local network, POP network, and then it also launches the Polkadot relay chain. That is then, my parachain is then registered on the Polkadot relay chain and will actually start producing blocks. So we can look here at parachains, and we see my parachain is right there, connected to Polkadot, and yeah.
Okay, I'm sorry. I know I'm monopolizing this. I hate how many questions I'm asking.
It's
But,
okay.
What you just is this localhost, or you actually deployed this parachain and that's live on Polkadot right now?
This is localhost.
Okay. So this isn't like live. Okay, then the other one I have. Can you explain a little bit better what happened when you just launched that R0GUE? Because I'm not deep into Polkadot or anything like that, but I noticed earlier that R0GUE in brackets contracts showed up on your chain options on the either faucet or something else. Were you were you saying like give me a parachain that is a clone of R0GUE? Anyways, I'll let you explain whatever happened in that command line, but I didn't understand what was going on there.
Yeah, okay, so POP network, basically that was the parachain that I was in. I used that one because it was pre-built. But we need that relay chain, because the parachain by itself can't actually do anything. There are, just to be clear, you can build a solo chain using Substrate framework or the Polkadot SDK. But this one is specifically geared towards it has to send messages to the relay chain. So I needed that relay chain. R0GUE is a Polkadot testnet. Paseo is also a Polkadot testnet. So I launched basically in my configuration file to launch it. I can show you that as well. It's this one here. So I'm going to go ahead and close that out, and then we can do.
So what you were doing there,
I don't know if I want the mic on this, but like what you were doing there is you were saying, okay, I want this chain to be connected to R0GUE, which is testnet like relay chain. Am I right?
It actually launched a local R0GUE.
So yeah, it's launching and then connecting the two because your parachain can't exist without the relay chain. And
Exactly.
we made an EVM parachain, and that was now connected to the R0GUE loco.
Yes.
R0GUE loco.
It's a tongue twister. It's a tongue twister. I make that same mistake every day. Yeah, so basically, yeah, we just launched a R0GUE local relay chain with 2 nodes running it, and those are validators. And then we launched a POP network one, and we launched a collator for that. So then we now have R0GUE, we've got POP network, and they're now doing stuff locally. Yeah. Yeah. Thank you.
Thank you so much. Yeah.
Yeah, thank you.
One more.
Yes.
Are we out of time? I don't need to ask this.
You can ask more.
Okay. So what would it look like to then deploy that chain? Like now that we've built this local parachain, how complicated is it to now, launch, make it live?
Yeah, so
Is that something that POP helps with, or is that kind of like you're on your own after that?
it's doesn't help with it just yet. We are working on some stuff to make it easier, but there's a lot of really cool projects out there. Like this one is really, really cool. So Tansy is app chain deployment made easy. So we can launch up their platform, and if you want to deploy just a chain and like have it live, you just like go and it's like, okay, I want a Snap app chain, which is just like a 48-hour ephemeral network that you can then test stuff with. And it's like, okay, I want substrates, I want to do all these things, and it will actually launch it in production, ready to use, but it's there's some cost associated with it, of course. So, but Tansy is really cool. Parachain as a service, exactly. So Tansy's a really good option for that, and you can actually then, if you wanted to specify a custom chain, so you build your local chain, you do customization, you can launch that too.
Okay, so we're getting short on time here, Peter. Is there any last things you want to wrap up with? Any last questions maybe that want to be asked?
Yeah,
I guess
let's
we can
do that.
chat. We're gonna all be around here. You guys can chat with us. So maybe we can move the chairs a little bit more forward because there's more people coming in. And Peter, thank you so much.